Okay, let's go ahead and start talking about our lesson today, 4.6, isosceles and equilateral triangles. Our I can statements for today is I can use properties of isosceles triangles as well as I can use properties of equilateral triangles. So let's go ahead and talk about some of these terms that we want to use today. The first one here is legs of an isosceles triangle. So hopefully you guys remember from 4.1 that isosceles triangle is a triangle that has two congruent sides. So what the legs of those isosceles triangles look like here would be these two standing up here legs that I'm pointing at. So those would be the legs of the triangle. Our vertex angle here, our vertex angle would be the top angle. So I will draw a line there. That is our vertex angle. And our base angles here are going to be these green angles. Okay, so here, I'll point there, base angles. Okay, so that's just some terms that you're going to want to know moving forward. So let's go ahead and get into our first definition. Our first definition here is the isosceles triangle theorem. So it's really important that we understand what this is saying. This says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So, for example, if we have an isosceles triangle here with angle 1 and angle 2, then the angles that are opposite of these sides are congruent. So if I can draw an arrow here to angle 2, I'm going to draw an arrow to opposite of this side BC here, and this is saying that angle 1 will be congruent to angle 2. Okay? So in isosceles triangles, two congruent sides, two congruent angles. Make sure we remember that. Obviously, the converse would work the exact same way. So this is basically just saying, hey, if we have two angles that are congruent in a triangle, then the sides opposite those angles are congruent. Okay, so when we say opposite, I want you to do this. I want you to take a line, draw it straight out from your angle. Whatever side you run into will be the side that is opposite of that angle. All right, so if we did it both for angle 1 and angle 2, we would find out that DE is congruent to FE. Okay, so that's what we're going to be doing here. Make sure we understand what's going on. Right here, name two unmarked congruent angles. So what we're going to do is we're going to essentially just look at our sides that we know are congruent. We're going to draw arrows to the angles opposite of those sides. Okay. So here, if I am looking at CB, looks like the only line or the only angle I can draw an arrow to with a straight line would be angle A. So here we're going to say angle A will be congruent to the angle that is opposite here of AB. So the only angle here we could reach from AB would be here, angle C, opposite of AB. So we're going to say angle A is congruent to angle C. I want you to also notice real quick here which angles we chose based off of our letter. So the angle that was opposite of BC was angle A. So the angle opposite of BC was angle A. The angle opposite of AB was angle C. Right? So if you notice, BC, what was opposite of BC? A. AB, what was opposite of AB? C. So when we take our two segments here, it's most of the time it's just going to be the third angle. BC, well, the opposite of BC was our third letter here in this triangle, which was A. Same thing goes AB. The letter opposite of AB was the only other letter that we had left in that triangle, angle C. So try to use that there kind of as a tool to help you. Same thing here. We're going to mark the two, or we're going to name the two unmarked congruent segments. So they show us here two congruent angles, angle C, angle D. And we're going to go ahead and find the two sides that are congruent by looking opposite of these angles. So angle C, we're going to look opposite of, which we could just draw an arrow straight out of this angle. And that arrow is going to point to segment BD. All right, so BD is going to be congruent to the side that is opposite of angle D. So if we drew a straight line out of angle D, Well, angle D would be opposite of BC. Okay, BC. So there are two unmarked congruent segments here would be BD and BC. Again, look at, so C was the angle we started with. Well, guess what's opposite of C? The two other letters in the triangle. Likewise for angle D. What is opposite of angle D? The two other letters in the triangle. So that can help us figure out which sides are opposite of our angle. All right, go ahead. I want you to try to do this one on your own and then check back in. Okay, which statement correctly named two congruent angles? So here, if we have these two congruent sides, then we will know here that everything opposite these sides is going to be congruent. So if we look opposite of JM, well, opposite of JM here would be angle K, but this would be the entire angle K. So this is going to be MKJ, MKJ, this whole angle here. So I'm just going to write it down just for us to remember and then help us go look at the answers here to make our choice. So MKJ, and then opposite of KJ, opposite of KJ here, if we drew a line straight out of this side, we would run straight into angle M. So this is going to be angle KMJ. Okay, angle KMJ. So we got to pretty much find out which one of these says what we have. So MKJ and KMJ, they may be kind of flipped around a little bit, but that's okay. So P, we don't really want anything that has to do with P, so we will kind of get rid of that. JMK, JMK, and JKM. So if you look, looks like this kind of, if we were to rewrite this, if we flip these, and we could actually rewrite this as JMK, right? Because as long as that middle letter there, that's all that matters. So angle JMK, we flip this over here, that's going to match up perfectly with letter B. So we went ahead and did our answer first before looking through the options, which is okay, but we should have had their letter B. Okay, this example right here, which statement correctly names two congruent segments? Well, since we are talking about congruent segments, I'm assuming that we're going to have to look at these congruent angles first. Okay, so looking at these congruent angles first here, we know that any segment opposite of our two congruent angles will be congruent. So draw an arrow straight out of angle M. Well, we're going to run into side PK. Okay, side PK. So I will go ahead and put a hash mark here. Same thing goes for K. Go ahead, draw an arrow straight out of angle K. You are going to run into the side opposite of angle K, which is MP. So looks like here our two congruent segments are going to be MP and PK. It does not really matter how we write that. So MP and PK, nope. MP, nope. PJ, no way. JK and MK, nope. PM and PK, there we go, right there. So our option here is D. Okay, so much like how isosceles triangles have two congruent sides, two congruent angles, equilateral is kind of the same thing, except for equilaterals will have three congruent sides and three congruent angles. Okay, so equilaterals are super easy to deal with because everything's the same. We don't ever have to worry about anything being different. All the angles are always going to be 60. All the sides are always going to be congruent. So equilaterals here will be pretty fun to deal with. Just know that everything is always equal. So here, you got to find the measure of angle R. Well, if this is an equilateral triangle, we would definitely know what that is, but we can't be for sure that this is an equilateral triangle. So what we're going to do here is we're going to look and see, hey, this is 5 centimeters. This is 5 centimeters. So we know that the angles that are opposite of both of these sides will be congruent. So the opposite angle of RQ is going to be the third letter of the triangle, angle P. The opposite angle here of PQ will be the third letter in the triangle. which is angle R. And now we can see here that these two angles here are equal, right? So we know P is equal to R. And if P is equal to R, and we know that Q is 60, this is what we could do. We could say X, we could say X. We know this is 60. So we could take our three angles here of the triangle. 60 plus X equals 180. And we could solve for angle R this way. Now I will tell you guys, it doesn't happen often that the answer will always come out to 60. In this case, this will be our answer because this is in fact an equilateral triangle, but we did not know that this was an equilateral triangle until doing this. So nowhere on here did they say this is an equilateral triangle. But after we do our work here, we are going to come to the terms of X is equal to 60. So we could say the measure of angle R is equal to 60 degrees. Measure of angle R is equal to 60 degrees. Right here, we got to find PR. Okay, got to find PR. So this looks like the same exact question we just dealt with. We knew that this was 60 degrees, which means that this is also 60 degrees. So this is in fact an equilateral after we just found the two angles in the past question. So since this is an equilateral triangle, we know all three sides are going to be the same. Two of the sides are 5 centimeters, so we can tell here that this will also be 5 centimeters. Couple more here. Looking for the measure of angle T, which is right here. Looking for the measure of angle T. Now, they do give us two sides. They give us one angle. I noticed 3.5 is here, which is congruent to the 3.5 over here. So if we can find the angles here that are opposite, those are going to be the same because 3.5 is congruent to 3.5. So here, opposite of 3.5 would be angle S. For RS over here, opposite of RS is going to be angle T. So these are going to be congruent, which would tell us here that this is 60 degrees. So the measure of angle T equals 60 degrees. TS, okay, TS. If this was an equilateral triangle, here, we would be able to tell what TS is. So this is 60, this is 60, that's 120 degrees so far. If we add those two angles, we know all triangles add up to 180. So 180 minus 120 would give us angle R here, which is 60. So yes, equilateral triangle, all three angles are 60. TS would have to also equal 3.5. Okay, TS would also equal 3.5. All right, two more. It says here, find the value of each variable. This looks to be an isosceles triangle by these hash marks here. So we've got 6y plus 3, we've got 4x minus 8, we've got 4x minus 8, we've got 8y minus 5. So what we can do here is, first, if we wanted to deal with these sides, we could kind of look at the opposite sides, look at the opposite angles, from these sides here and see what is congruent. So I'm going to go ahead and start off by just labeling what's congruent. So I know these two sides are congruent, so the angles opposite are going to be congruent. So opposite of FE was angle D, opposite of FD would be angle E. So here 4x minus 8 is going to be congruent to angle D. And if we wanted to solve this for y here, we could do that right off the bat. We know 8y minus 5, 6y plus 3, those have hash marks that says that they are congruent to each other. So we're going to say 6y plus 3 is equal to 8y minus 5. And we'll solve this pretty quickly here. Subtract a 6y from both sides. Get 3 is equal to 2y minus 5. Add a 5 to both sides. 8 is equal to 2y. And we're going to get y equals 4. Okay. So y is equal to 4. Now, we got 4x minus 8 here for angle E. and 4x minus 8 here for angle F. 4x minus 8 and 4x minus 8, the exact same thing, right? So if we know that this is 4x minus 8, I'm going to actually erase some of our lines here in the middle. Okay, so if we know here that these two angles are congruent, right? Angle D, angle E. Angle E is 4x minus 8. That means angle D would also have to be 4x minus 8, right? They also give us angle F and tell us that that is 4x minus 8. So all three angles here are 4x minus 8. So we know if we have what all three of the angles are, we can add those up and set them equal to 180. So essentially what we're going to do is we are going to add 4x minus 8 three times and say that that is equal to 180. Or we could also just multiply that by 3. Okay, so 3 times 4x minus 8 is equal to 180. This is just using the distributive property because we know that there's three angles. All three angles are the same thing. So this is no different than just saying 4x minus 8 plus 4x minus 8 plus 4x minus 8. So here we're going to get 12x minus 24 equals 180. We're going to want to add a 24 to both sides. And this is going to be 204. We're going to divide both sides here by 12. We should get x equals 17. All right, so y equals 4, x equals 17. Last one. Last one. I want you guys to do this one on your own and then come back and see how you did. So starting off, got an isosceles triangle. We know this is 4y minus 2. This is 2y plus 2. Let's go ahead and solve that first. They're equal to each other. All we need to do is set them equal to each other. Okay, 4y minus 2 equals 2y plus 2. So I'm going to solve this in one step real quick. It's going to be 2y equals 4. Divide both sides here by 2. Y equals 2. All right. 6x plus 8 here is one of our angles. Let's look at this. So let's find our congruent angles. Opposite of 4y minus 2 would be this 6y plus 8. Opposite of 2y plus 2 would be our angle over here. Okay, so we know that this is 6x plus 8. We know this is congruent to 6x plus 8, which tells us this is also 6x plus 8. And we know here that this vertex angle, the top angle, is 80. So what we can do is we could say 6x plus 8 plus 6x plus 8 plus 80 equals 180. Okay, and we'll solve here using like terms. So this is going to be 12x plus 96 equals 180. Go ahead and subtract that 96 there from both sides. And this is going to be 12x equals 84. Divide both sides here by 12, and we are going to get 7. Alrighty. Hope this helps. If you guys got any questions, send me an email.